Okay, where I left off with this problem was I just found the area of this big portion here, the portion that had a radius of 30, and had that central angle of 270 degrees. I found out that that area was 2,120.58 meters squared. The next one I'm going to do is find the area of this sector that has radius 15 and that angle of 90 degrees. Okay, so kind of like what we did in the first part or the end of the last video, you find the area, and that is pi times the radius squared. This time my radius is 15, because remember, like what's happening here is if I have a rope that's 30 meters long, it goes all the way up to here. It goes from here all the way up to here, but that has that that overlapping of 15 meters. Because that side length's only 15, and so we form this other sector here. This gives me, actually, when I plug in that radius of 15, that's pi times 15 squared, which gives me 15 squared is 225 pi. All right, now we got to multiply it by the portion we want. The portion we want is just that 90 degrees in which that exists, and so 225 pi times the 90 out of 360. This reduces that 90 over 360 reduces down, so this is 225 pi. This reduces down to 1/4. And when I multiply this here, I get the area of that part, that sector. Sorry, I get my calculator up. 225 pi. And we get that portion right there is 176.71 meters squared. All right. So now I have two of my three sectors. I have the red one done, the one with radius 15 done. I have the one with radius 30 done. The last one I'm going to need is that one that has radius 5. And then I'll have all three sectors, and I'll have the complete area once I add them all together. So this is, oh, I didn't mean to cross all that out. I wanted to underline it. That is 1. This is 2. Let's find 3. Okay. And so the last one, pi times radius squared. This time my radius is 5. My radius is 5. Because it goes the whole 25 and still has 5 left to create a new sector. And so this is pi times 5 squared. That is 25 pi because 5 squared is 25. And the portion of the sector I'm looking for, again, it hits that corner and forms 90 degrees. And so it is 90 over 360. Okay, that's going to reduce down like it did in the last one. This is 25 pi being actually multiplied by 1/4. And this is what I plug into my calculator. 25 pi divided by 4, same thing. And that gives me 19.63 meters squared. Now I have the area of all three of my sectors. That's the third one right there. That's the third one. All right. And now I just got to add them all together, and I'll have my complete area. So let's take the first one, the 2,120. 2,120.58 plus my other one, or plus my next one, which is 176.71. And then I add it to my third one, which is plus 19.63. And this, if I added it up all correctly, will give you my answer. I got to do it on my calculator though, so I don't make any mistakes. 2,120.58 plus 176.71 plus 19.63 gives me a final answer of 2,316.92 meters squared. Recapping that one just quickly, we found the area of the big portion, the radius 30 portion, found the area of the radius 15 portion, and found the area of the radius 5 portion and added them all together. And again, it's always just using the area of the sector. I said in the beginning of this problem, in the second video, it is when you have to draw out. Otherwise, you would never see how many degrees, or maybe you would think it would be inside of that rectangle, and it would change everything. So it's a good one to draw out. You get to see, you know, the 270 degrees, you get to see the 90 degrees, you get to see the changes in radiuses because of the side lengths take up so much of your rope. It's really actually a great problem. It's practicing it. I mean, by the time we did C, we've practiced it like 7 times. Let's do part D though, and we'll move on. And so it's saying that Zoe is the happiest when she has at least 400 meters squared to graze. And it's saying, what is the possible lengths of rope that could be used? So we know, I mean, we could look at it going back, and when it was 10 meters, it wasn't long enough. When it was 20 meters, it was long enough. So it's going to be somewhere between 10 and 20. And we want to find out just exactly how much rope would be perfect for that. So I'm going to actually erase my ink here. And I actually don't really need this box here on this one. What I know is I'm just going to kind of like do what I was doing before on this problem, but we don't know how long the rope is, so we don't know what radius we want. And so I'm going to do this problem kind of like I was doing it, but I don't know the radius. And so we have pi times my radius squared, and maybe I will actually draw it out. I wasn't going to, but maybe I will. So we're looking for what that radius needs to be so that the area here is 400. We know that in all of our problems that area of the circle was always multiplied by 270 over 360. So that's the angle we're still going to use for the grazing. And we know that this answer has to be at least 400 meters squared. Okay, we know it has to be at least 400 meters squared because that's when Zoe's the happiest. And honestly, with this setup here, I believe I'm able to solve for the radius and come up with how long my rope has to be. The first thing I'm going to do is I'm going to divide both sides by this fraction 270 over 360. Divide this by 270 over 360 so that this goes away, and I'm just going to be left with pi times the radius squared equals whatever that division gives me on the right side. So I got to use my calculator here, and I have 400 divided by, and now I'm going to put this in parentheses, 400 divided by 270 divided by 360. And what that gives me, if I plug it in correctly, is 533.3, and that's still meters squared technically. And now I'm one step closer to finding out what my R has to be. The next step I'm going to do, divide both sides by pi, because I'm trying to really get R by itself, which means I have to divide this side by pi. The pi's now cancel, and I'm left with R squared equals this number, 533.3 divided by pi, which gives me 169.75. And now I have R squared equals that thing. To make this just R, I just want R, not R squared, I need to square root both sides. And that means that R, the square root of 169.75, which is actually 13.03 meters. And that is the length of the rope where she will have, or Zoe will have, 400 meters squared of roaming room. All right. The problem is saying, however, what is the possible length of rope? Well, 13.03 meters is where she'll hit 400, that 400 meters squared grazing area. So anything bigger than 13 meters will work. And so really our answer is that you really want a radius that is greater than or equal to 13.03 meters, because if it's greater than that length, she'll have at least that much room to graze. And so there we have the answer to part D. And with that, we have A, B, C, and D done, and let's move on to 8.1.15. Okay, This one I think I can do in the time remaining, but it's going to be kind of quick. So what it's saying is this cookie baker has an automatic mixer that turns out a sheet of dough in the shape of a square that is 12 inches wide. His cookie cutter cuts 3-inch diameter circular cookies, and it's shown to the right. The supervisor complains that too much dough is being wasted and orders the baker to find out what size cookie would create the least amount of waste. And so we are going to just kind of change the size of the cookie. We can't really change the way that the automatic mixer works. It always creates a 12 by 12 square of dough. But we are going to see how many cookies, or if there's a different diameter of cookie that would work to find this, or to minimize the amount of dough wasted. And so let's just kind of look at what it says. You know, my task is to start kind of with a 3-inch cookie and see how much dough is wasted. And so let's do that, and let's kind of just start evaluating this and just going through it. All right. We have like it said in the problem, it creates this sheet of dough that is, and that's not correct, but that's what I'm going to go with, is 12 by 12. So it's supposed to be a square. Okay. And they're saying that we have cookies getting cut out of here that have a diameter of 3 inches. Okay. And so kind of like the picture actually has up here, it would take 4 cookies across. It takes 4 cookies across to take up that whole 12, and it takes 4 cookies down to take up that whole 12. Okay? Where I should start, sorry, that kind of was a little bit of a tangent. Where I should start is the area of just the dough. The total area of the dough that's created when we use the automatic mixer, and that is our length times our width, which is 12 times 12. So we always have 144 inches squared of dough before we cut any cookies out of it. Okay? Now, kind of back to my point, what I was doing before is if it takes 4 cookies across and 4 cookies down, we have these cookies that are 4 by 4 when the diameter is 3 inches. All right? Which means that we have 16 cookies that you can get. If their diameter is 3 inches, you can get 16 cookies out of that 12 by 12 dough. All right, and so we get the 16 cookies here if our diameter is 3 inches. Okay, so now what we can do is we can find the area of one cookie, multiply it by 16, and that's the area of all my cookies. We could subtract that out of the total 144, and we could see how much is left, how much waste is left. Okay, now I have to find the area of that one cookie. Area is always, again, area equals pi times the radius squared. Well, my diameter is 3, and my radius is always half of my diameter, so really what I get here is pi times 1.5 squared, because 1.5 is half of 3, and 3 is my diameter. All right? And what this gives me then is 2.25 pi is the area of one cookie. So that's the area of just one cookie. Well, I said that I could get 16 cookies on that sheet, and so I got to multiply this 2.25 pi times 16, and the area of all my cookies. All right, the area of all my cookies created, if it's 3-inch diameter, is going to be 36 pi, if I calculate it out. Now, to talk about how much waste we have, well, we started with 144 inches squared of dough. We are going to make all these cookies, which accounts for 36 pi inches squared of dough. And I'm subtracting that out because I'm looking for what's the waste is, which is like the dough we're not going to be able to use. And so whatever this equals would be the waste. Okay? Now, let's see. I'll just plug it into my calculator quick. And then I'm going to have to finish this one on another video because I'm out of time. I'm sorry. That's 4 videos. I promise that they won't always take this long. 144 minus 36 pi gives me approximately 30.9 inches squared of waste. And we're going to see in the next video if we can minimize that.